And for our next section now, section 4.3, we're going to need all this information from our previous sections. We first started off in section 4.1 talking about standard form, ax plus by equals c. We talked about vertical and horizontal lines and what they look like in terms of their equations. And then most recently in section 4.2, we talked about that alternative linear equation, the slope-intercept form of y equals mx plus b, okay, where you get your slope and your y-intercept. And it's all of this information that we will need for section 4.3, where we're going to be talking about writing equations of a line, okay? This is as close to word problems as we get in this particular course. I know you're disappointed by that. Everyone loves word problems. But we're not going to have any real word problems here. But these will be, like I said, as close to word problems as we're going to get because they are problems with words. Okay. For example, I could ask you to write the equation of a line, and let's say you are given the fact the slope is, let's say, 1/2, and maybe the line passes through the point let's say that point might be -4, 6, okay? You're going to be asked to write the equation of a line. We are told what the slope is. We know that the slope is 1/2. That's a given piece of information. And we are also given a point of x1, y1, and that ordered pair is -4, 6. Okay? Now, if we're asked to write an equation, we don't have to graph anything. Okay? So we are looking for an answer in the form of an equation, which means it could take standard form. It could look like this. It could look like slope-intercept form, y equals mx plus b. It could look like x equals some number a, or y equals a different number b. And in this particular case, more often than not, most people prefer to use slope-intercept form. So we're looking for our answer to resemble y equals mx plus b. And here's how we're going to find the answer. Well, part of the answer is actually already given to us. We are told that the slope m is 1/2. So we can fill in that information. Y equals 1/2 x plus b. Now we just have to find b. Okay? If we could figure out what b is, we have our answer. And we can do that because what we're going to do now is we're going to use the ordered pair of x and y, which is given to us as the numbers -4, 6. And we're going to plug these numbers. -4 will get substituted in for x, and the 6 gets substituted into y into the equation. So y is 6, m is 1/2, x is a -4, plus b. We don't know what b is yet, but now we have enough information because we would simplify. 6 is going to equal half of the -4 would give us a -2 plus b. And when we solve for b by adding the 2 over, we get b is 8. And so now we also know that the b value is 8, so now I could fill that information in. And we would have our solution, our equation of y equaling 1/2 x plus 8. That one's done. That one wasn't too bad. Okay. Let's try a different one. Once again, I could ask you to write the equation of a line let's say we are given the slope, let's say, is -4, and the line passes, let's say, through the point let's say it passes through the point maybe 3, -2. Okay? Once again, we have the slope is -4, and we are given an ordered pair of x, y has the numerical value of 3, -2. So, once again, let's start by coming up with our original form, y equals mx plus b. And since we know that the slope m has a numerical value of -4, let's plug that in. Y equals -4x plus b. Now we have to go and figure out the numerical value of b. And we can do that. Once again, I'm going to use our ordered pair and the slope, and let's plug in to our formula. Y is -2. M, we said, is -4, times x, which is 3, plus b, the unknown y-intercept. When we simplify, we would get -2 equals -12 plus b, and when you go to solve for b, you get b is 10. And so now we can figure out and plug in that particular value of 10, giving us our answer. Okay? Any questions so far about that one? That's not too bad. Okay? I'm going to change it a little bit. Okay? Let's say I'm going to change this problem a little bit here. I'm going to change just the slope. Let's say we have a slope of 0, and it's still going to pass through the point of 3, -2. So now we have a slope of 0, and it's still passing through the point, the xy, of 3, -2. Well, the fact that we have a slope of 0, we've heard that before, okay? Our slope isn't positive, our slope isn't negative, we have a slope of 0. And whenever you have a slope of 0, if we recall our earlier notes, we said that whenever we have a slope that's 0, it will always be a horizontal line. And we furthermore said that whenever we have a horizontal line, the equation will always read y equals some number. Okay? So that's the equation we're going to use. I'm not going to use slope-intercept form. Okay? So because we have a slope of 0, I know my answer has to take the form of y equals some number b. Well, so all I need is a b value. And I have a y value. Y, according to the ordered pair, y equals the -2. So my answer will be y equals -2. It's just that easy. Okay? So if you have a slope of 0, your y is going to equal a number because it's going to be a horizontal line. To get that y number, look at your ordered pair. Okay? Let's change it one other time. Okay? Let's say we have now, instead of a slope of 0, let's say given the slope is undefined. Okay? And it's still going to pass through the point 3, -2. And so now our slope is undefined, and our xy is still going to be 3, negative 2. Well, let's think about when we said we have a slope that's undefined. Well, if we go back to the notes, a slope that is undefined will always be a vertical line. And we know all vertical lines take the form of x equals a number. And so, for this one, if we have a slope that's undefined, we know our answer must take the form of x equals some number a. Well, all I need is a number for a. Luckily, we are given in the problem that x has a numerical value of a positive 3. And so our solution would be x equals 3. All the information was right there, okay? We didn't have to calculate anything, all right? Let's try a different one, okay? In these problems, you were given the slope and you were given a point. But that might not always be the case. For example, I could ask you to, let's say, write the equation of the line that contains the points and let's say our points are 3, negative 4 and 6, 5. Okay? Now, in the 3 previous problems, you were given the slope and a point. Okay? Now, here you are not given a slope and a point. Instead, you are given 2 points. And for that, okay, the most important piece of information is the slope, and we're not given the slope. So the first thing that we're going to have to do is we're going to have to find the slope. And luckily for us, we learned in the previous section that y sub 2 minus y sub 1 over x sub 2 minus x sub 1 allows us to find the slope. And we are given an x1, y1, and we are given an x sub 2, y sub 2. So we can go and find the slope. So let's do that first. Y sub 2 has a numerical value of 5, minus y sub 1 has the numerical value of negative 4. X sub 2 is 6, and x sub 1 is 3. And when we simplify, we get 9 over 3, which is 3. So now we have a slope of 3. And now I have a choice, okay? I still need to find my equation in the form of y equals mx plus b. We're not done with the problem. And I have the slope, but now I need to go and figure out what is b. Well, I have a choice here. I could use either point, okay? I guarantee if you use either point, you will come up with the same b value. And I'm going to show you, in case you don't believe me. Let's say we were to use the point of 3, negative 4. Okay? Let's plug in our slope and our x and y value, and let's see what we get for b. So y is negative 4 equals m, which is 3, times the x value, which is also 3, plus b. When we simplify, we get negative 4 equals 9 plus b, in which case b equals a negative 13. So we could write y equals 3x minus 13 as our answer. But I know what you might be thinking. What if I picked the other point of 6, 5? Would I get the same equation? Well, let's see if we do. I'm not sure myself. in which case now we're going to plug in 5 for y equals, the slope is still 3, times the x value, which is now 6, plus b. When we simplify, we get 5 equals 18 plus b. Subtracting the 18 over, look at that. B is still a negative 13, okay? In which case our answer would be the same of y still equaling 3x minus 13. So how about that? If we have the slope using these 2 points, it doesn't make a difference which point you use to figure out the b value, because we in essence get the same value, as we should, because they are forming on the same line. Okay? So you must have the slope. It's extremely important to have that slope. If you are given the slope, awesome. If you are not given the slope, we have a way of calculating it using that formula from section 4.2. Now, the last thing that we have to talk about are 2 very special lines, and what makes them special particularly is the slope. First, let's talk about lines that are in fact parallel to each other. Parallel lines, you've probably heard of before. Parallel lines are 2 lines that never intersect, never meet, okay? They do have to be coplanar, which means they're on the same plane, but that's getting real technical, okay? But what's more important is something special about their slopes that makes the lines parallel to one another. Now, all parallel lines are going to have the same slopes. Okay? So, if I gave you, let's say, y equals 2/3 x plus 5, and I asked you to write me an equation that is parallel to this, there are an infinite number of correct answers. Okay? One person could say y equals 2/3 x minus 5. Someone else could write y equals 2/3 x plus 7. Someone else might write y equals 2/3 x. Okay? And all of these answers are correct. Why are all of these lines parallel to the one that I gave you? Because they all have the same slope of 2/3. And as long as they have the same slope of 2/3, all of these lines would be parallel to one another. Okay? What if we gave you this? What if I had, let's say, 4x minus 6y equals 13? Is this equation parallel to all the others? Well, your initial instincts might tell you, well, no, they look so different, okay? Well, that's because of the form that it's in. Remember, these equations are in that slope-intercept form of y equals mx plus b, where to find the slope, you have to look no further than the variable, or should I say the number in front of the x. But let's take a look here. Is this equation parallel to the others? Well, remember now, this particular equation is in standard form, ax plus by equaling c. And to get the slope of this equation, I gave you earlier the other day a formula that we have to take the opposite of a and divide it by b. Well, a is 4, but I need the opposite of a, so that would give us negative 4. b is the coefficient, the number in front of y, which is a negative 6. And now let's take a look at this fraction. Negative 4 over a negative 6. That does simplify to 2/3. So sure enough, this has the same slope as all the others. So therefore, this equation would also be parallel to the others. Okay? So don't get hung up on the fact that it has to be in slope-intercept form. If you were to give me an answer in standard form, as long as it has the same slope, you're good to go. Okay? Another type of line that's special, that's not parallel, would be perpendicular. We also have to discuss those as well. Now, what makes lines perpendicular also is something about the slope. When we have perpendicular lines, the slopes must be opposite. Now, we've heard that term before. And reciprocal. And that's another term we've heard as well. When you talk about opposite, okay, that means you have to change the sign. If something is positive, you make it negative. If something is negative, you must make it positive. What do we mean by reciprocal? That means you have to flip the fraction. If your fraction was 2/3, you flip it. You make it 3 over 2. If your fraction was, let's say, 1/3, you flip it. You make it just the number 3. So that's what's meant by opposite and reciprocal. So for example, let's say you are given the equation y equals, let's say, 5/3 x plus 1. And I want an equation that is parallel. I'm sorry, not parallel, perpendicular. Once again, in order for these lines to be perpendicular, we want to look at the slope that we are given, and then the slope that has to be perpendicular. So the slope that we are given is 5/3. Now, the slope that has to be perpendicular, and this is the little symbol that we use to represent perpendicular, once again, has to be opposite and reciprocal. So I start by looking at this slope, and this slope is a positive number, so I have to change it. Has to be negative. But I also have to take my fraction and flip it. So instead of it being 5/3, I'm going to flip that fraction and make it 3/5. These are opposite and reciprocal slopes. And so now, if I want to write an equation, I could write y equals negative 3/5 x plus 1, and that would be perfectly fine. I could write y equals negative 3/5 x minus 2, and that would be perfectly fine. These two equations would be perpendicular to the one that's given. Why? Because we notice the slopes are opposite and reciprocal. Okay? Let's take a look at some problems now that deal with parallel and perpendicular lines. I could ask you to, let's say, write an equation that is parallel to, let's say, y equals 2x minus 4, and passes, let's say, through the point 3, negative 6. Okay, I'm trying to come up with an equation it has to be parallel to the given equation, but it must also pass through this point. Well, the slope that we are given, if we look at our equation, we have a slope of 2. The slope that is parallel, and this is the little symbol that we use for parallel, has to be the same slope, also 2. But now, I also have to pass through the given point. I am given the information of xy as being 3, -6. So now I have enough information to come up with my equation that y equals mx plus b. And I'm going to plug in my information to figure out the b value, in which case y is -6. The slope is the parallel slope, 2, times x, which is 3, plus b. As we simplify, -6 would equal 6 plus b. And as we solve for b, we get -12. So therefore, my answer would be y equals 2x minus 12. This equation will be parallel to the given one because it has the same slope, and it will also now pass through this point, the point that we were given of 3, -6. Let's just try one more. Let's say you are asked to write an equation that is going to be now perpendicular, let's say, to the equation 2x plus 3y equals 5, and let's say passes through the point let's say the point that we are given is -4, 5. Okay. So first of all, we need the slope. Well, to get the slope of the equation that we are given, we need the opposite of a over b. Well, a is 2, so I need the opposite of a, -2, over b, which is 3. So the slope of the equation that we are given is a -2/3. But now remember, we need the slope that is going to be parallel. So I need the opposite and reciprocal slope. Opposite means I change my sign, so that's positive. Reciprocal means I have to flip the fraction, 3/2. So now we have the slope that is perpendicular, and we are also given, once again, an xy coordinate of -4, 5. And now I have enough information and that I can solve for my equation. Y is going to equal mx plus b. And let's plug in what we can. Y has a numerical value of 5. The slope that we're going to use must be the perpendicular slope of 3/2 times x, the x value is -4, plus b. Let's simplify what we can. 5 equals, if we were to multiply 3/2 times the -4, that of course would give us a negative, I believe that's a -6, plus b. And to solve for b, you would add 6 over. b equals 11. We have our b value, we have our perpendicular slope, so therefore our answer would be y equals 3/2 x plus 11. We have now written an equation that is perpendicular to the given equation and will pass through the point negative 4, 5. Okay, so we see here that we used a lot of information from the previous section, okay, which is why I reviewed it at the beginning, okay. Here we have all that information that we're going to need about standard form, how to get its slope, vertical, horizontal lines and their slope, slope-intercept form, and the importance of the information found within there, okay? Key was the slope. You needed that whenever we are asked to write an equation. If you are given the slope, great. If not, if you were given 2 points, not to worry, as we demonstrated, that you can find using that slope formula of change in y over the change in x. Okay. Then we finally talked about parallel and perpendicular lines. Remember, parallel lines must have the same slope. Very important. When we talked about perpendicular lines, the slopes must be opposite and reciprocal. Okay. That concludes section 4.3. The next time we have to take a look at one more section of this chapter, section 4.5, which is an intro to functions. Okay. Try the homework and email me any questions or concerns you may have. Until the next time, be well.